Next, we'll be hearing from Tim Nesheim, who started working as a subsurface geologist for the North Dakota Geological Survey in 2010. Tim was promoted to head the subsurface division in 2017 and was promoted again in 2022 to core library manager of the Wilson M. Layard Core and Sample Library located in Grand Forks, North Dakota. Please help me welcome Tim.
All right, thanks, Brady, for that introduction. It's a little bit more than I usually get. Also, thank you to Ron Ness and the Petroleum Council for giving me a slot today and for your attendance and participation. Hopefully I don't put you to sleep. As introduced, Tim Nesheim, North Dakota Geological Survey. I'd like to give a loud shout out to co-author Ted Starnes, who's here today. Ted did a lot of the work, especially that shows up in the later half of this presentation. Today we're going to be talking about the Bakken Three Forks Petroleum System and one part of it that from the survey's work here that we feel may be being underdeveloped. So kind of taking a look at where we're at now, kind of giving an overview for those that are new, a refresher for those that you aren't. On the map on the right, that shows kind of a regional map where brown is the extent of the Bakken, green for Three Forks, and all those black dots are the tens of thousands of Bakken Three Forks wells that have produced oil and gas, many of which are still producing today. Most of those are horizontal, some are old vertical wells. On the left is kind of a wireline log suite through the section, kind of highlighting those black intervals are the Bakken shales. They're generating and expelling oil and gas. Your reservoirs, though, are not the source rock. We're in like a tight oil play, the source rock is or in a oil shale play, the source rock is a reservoir. This is a tight oil play where you're drilling in and around the source rocks, get the oil and gas out of the ground. And so the reservoirs that have really established in western North Dakota into regular development are the Middle Bakken, Upper Three Forks, and then kind of more locally the Middle Three Forks and the Pronghorn members. Of course, with that, this didn't just happen overnight, as it's kind of been talked about today. This is kind of a multi-decade journey for the Bakken to get to where it is today, and we're going to talk a little bit about that before launching into what's being underdeveloped. And so there are old vertical wells that go back to the 1950s. I think that was touched on in this morning, where the vertical wells hit naturally fractured rock. And then there was an early horizontal fractured shale play that was also touched on this morning that was in kind of the late 80s, early 90s. But really, the beginning of the trajectory of where we're at today started with Elm Coulee in eastern Montana, where the Middle Bakken was the primary reservoir. And then partial hit in 2006, which it did kind of step over McKenzie County initially, which was touched on this morning. And again, the Middle Bakken, that was the primary reservoir at that point. And then somewhere in the late 2000s, operators began to drill and test and establish the Upper Three Forks as another additional reservoir to develop in parts of the basin. And the current map, those green dots show a lot of those early Upper Three Forks wells that were drilled up until 2012. And then locally down in like the Dickinson, Medora area, outlined in red, the Pronghorn member became a local established reservoir. The Pronghorn is one unit that's a lot more geologically diverse for the basin. But yeah, locally it becomes a reservoir in the southwestern part of the play. A lot of the Pronghorn wells, though, if you look into databases, they're referred to as Three Forks wells and or Bakken wells. And so those were the first four reservoirs. And then starting in about 2013, actually the early wells were drilled in late 2012, completed in 2013. There were operators led by Continental Resources that started to drill and test the middle and the lower Three Forks, which are also referred to as the second and the third benches. At that time, and still today, there is a lot of skepticism if those Middle Three Forks horizons actually have any additional resource to add or not. Even though industry has drilled hundreds of wells in them. So the lower Three Forks third bench, we haven't seen a well drilled in it since 2017, so it really hasn't emerged in my mind as a regular drilling target. Meanwhile, the Middle Three Forks second bench, it has. And so the map on the right here, it's a bubble map where the bigger yellow, orange, red bubbles, those are the Middle Three Forks wells that have cumulatively produced hundreds of thousands of barrels in their first few years of production. The smaller purpley bubbles aren't very productive, and then green is in the middle, and then the water cut underlies that. And you can see a whole bunch of big bubbles in and around northeastern McKenzie County that are really good second bench wells. And on the other side of the slide, there's a diagram showing the production history of the Middle Three Forks and drilling activity. And so that red line is monthly gas production, green and blue is monthly oil and water production. The black line is the number of actively producing Middle Three Forks wells, which is somewhere over 300 presently. And then those black circles are the number of Middle Three Forks wells that were completed each year, going back to 2013. And so for the first several years of activity in the Middle Three Forks, you were seeing between 30 to upwards of 60 plus completions. And the peak year was 2018 with something like 62 Middle Three Forks wells were completed. And so up until 2018, there was steady production growth from this reservoir. But then from 2018 to 2019, there was just a drop-off in production, where over the last several years, we've seen about 20 new Middle Three Forks wells being completed each year. And at that rate, it's caused production rates to drop, where they've dropped and then leveled out at about 800,000 barrels of oil per month, about 27,000 barrels of oil per day, which is about 3% of the total Bakken Three Forks. And this is the part of the play that we're believing is probably being underdeveloped within the basin. The question is, why is it being underdeveloped? Well, there's skepticism. And with companies, oil and gas companies that have internal skepticism, it's not like you guys go out and publish reports, saying, hey, we think the Middle Three Forks is not an actual resource. So I have to pick on the USGS assessment because they published their data. And so USGS completed its last Bakken Three Forks assessment in 2021. And with that, they subdivided the Three Forks into 7 different assessment units based upon geology and production trends. I'd like to highlight just their one assessment unit, the Central Basin Three Forks Fairway, highlighted in orange there. In this assessment unit, going through their kind of data tables, explaining their different components of how they came up with their numbers for each assessment unit, a few things stood out to me. And also to point out, this assessment unit is where you're seeing pretty much all of the really good Middle Three Forks wells that have been drilled over the last 10 years. In this area, in this assessment units, they were assuming just 4 Three Forks wells per 1280-acre drill spacing unit, which is the same number as all of the other Three Forks assessment units, where the Middle Three Forks has not a lot of development potential. And also 4 wells is about the standard number of Upper Three Forks wells. So basically, the USGS assessment says there is no Middle Three Forks resource to be developed, even though I gave them a bunch of data that I'd worked on for years. When I emailed them and asked them about that, they said, basically reading through the lines, their email was basically stating that drilling and developing the Middle Three Forks is not volumetrically adding any oil. It's simply accelerating the oil you would get out of drilling and developing the Upper Three Forks anyways. I thought that was interesting. The other thing I thought that was interesting out of here is their average Three Forks well EUR in this spacing unit, or estimated ultimate recovery, is 160,000 barrels of oil. If at the current drilling and completion rates, that type of well production will not make you any money. You'll probably lose your shirt, your shorts, socks, your underwear. It's not a very high EUR, as we'll see in a little bit. There's a number of reasons that last USGS assessment had really low numbers. These are 2 of them. And so with that, myself and Ted Starnes more recently wanted to answer that question: is developing the Middle Three Forks rate acceleration? You're just getting the same amount of oil out of the ground faster, or is it volumetric addition? And so we've gone through and had 5 case study areas we've worked on. It's actually probably 6 because Elm Tree got subdivided based upon some geologic components. I'm not going to go through all this in detail, but just kind of give a quick overview. I'm going to start with Twin Valley, which is the case study area I worked on most, which is in north central McKenzie County, which is off the Nesheim anticline. In this area, there were 2 spacing units in the middle, highlighted there, that had wells stacked in the Middle Bakken, Upper Three Forks, and Middle Three Forks. The dotted lines there are the Middle Three Forks wells. Solid lines are Upper Three Forks. They're color-coded based on their first 3 years of oil production. We don't show any Middle Bakken wells because they're pretty much consistently drilled over all of these spacing areas. And if we added in the Bakken wells, it would just be a complete mess. But for each of our spacing units, we went through and first reviewed drilling records, did some reverse geosteering to basically confirm which reservoir horizon each lateral was drilled into. And so on this spacing unit, there were 6 Middle Bakken wells. We then also went through and tallied up the first 3 years of oil production for each well, and then we added that together for each spacing unit. So this example unit shown here had 6 Middle Bakken wells, and the 3-year cumulative oil production totals for those 6 Middle Bakken wells was about 2 million barrels, which is a hard number. We also did a decline curve analysis on each well to kind of estimate the ultimate recovery. Sometimes EURs are fairly straightforward, and sometimes they're not at all, but we did our best. And those 6 Middle Bakken wells we estimated will eventually produce about 3 million barrels of oil. So that's a projected number. We then went through and did the same for the upper 3 forks, and when applicable, the middle 3 forks. And so with this assessment, this spacing unit, 3-year oil cumes total up to about 5 million barrels, and eventually that spacing unit with current wells and completions will produce around 7 million. So in Twin Valley, basically we had the 2 spacing units with middle 3 forks. We had 4 we tallied up without, and the moral of the story is when you develop the middle 3 forks, you get more oil out of the ground faster, and you just get more oil out of the ground based on our projections. The 4 spacing units without middle 3 forks wells are going to average around a little over 4 million barrels per spacing unit. The ones with middle 3 forks is going to be about 7 million barrels. I have to say this was the most straightforward of the case study areas we looked at because of consistent development techniques. All the other ones were a lot more muddled. Touching on a few other ones, this is southwestern Elm Tree. We just had 5 spacing units we felt like we could compare. Story here again is with the middle 3 forks, you're volumetrically adding oil versus when you're not drilling it. The tough thing here, though, is some of those middle 3 fork spacing units that are on the left, they had 6 to 7.5 Middle Bakken wells, whereas the spacing units on the right without middle 3 forks, they only had like 4 Middle Bakken wells. And so that's where it's hard to compare these spacing units because we wanted to mostly focus on middle 3 forks, but then the Middle Bakken and upper 3 forks well density varied quite a bit too. And you might ask, how do you get half of a well in a spacing unit? And that's simply that you have section line wells that are drilled right along the boundary between adjacent spacing units that we had to subdivide. So again, overall, it indicates volumetric addition with the middle 3 forks. Last study area I'll look at was the northern part of Elm Tree, where we had more like 10 to 12 drilling spacing units. Thing I'd point out here is that light green at the top. 2 of our best producing spacing units had middle 3 forks development, which is encouraging. But then our best producing and projected spacing unit had no middle 3 forks wells. It just had a bunch of extra Middle Bakken and upper 3 forks. Also, we had 3 middle 3 forks spacing units that the middle 3 forks doesn't appear to have added much volume, at least based on our numbers. The middle 3 fork spacing units that haven't produced or added volume from developing the middle 3 forks, it looks like areas where the reservoir quality of the middle 3 forks is lower and the oil saturations aren't as high. And moral of the story to some degree is if there isn't a lot of oil in a reservoir, you're probably not going to produce a lot of oil out of it. So stepping back and just wrapping this up, overall between Ted and I, we evaluated 532 wells. And that spanned 45 drilling spacing units. 25 of those units had 1 to 4 or 5 middle 3 forks wells. And out of those 25, it looked like 17 spacing units, the middle 3 forks was adding some amount of notable added oil in terms of overall EURs. There were 2 colored in yellow where we weren't really sure, and then there were about 6 where it didn't look like middle 3 forks development was adding much. Some of those non-successful spacing units were simply where the middle 3 forks wasn't as charged up with oil. Some others in the middle part of that red outlined area, it was probably more of a well density issue. So Ted did an initial evaluation in that red outlined area where we feel like there could be pretty consistent middle 3 forks development. A conservative estimate is about 600 remaining middle 3 forks well locations. Ted ran numbers, statistics on the 62 Middle Three Forks wells in that area that we evaluated, and the average Middle Three Forks well is about 415,000 barrels of oil for an EUR. You add those numbers together, and it gives you around 250 million barrels of undeveloped resource in just that area. And if you step back, there's additional nice-looking Middle Three Forks wells to the south, and potential based on some other data we've looked at that this play could move to the north. And so those numbers of around a few hundred million barrels of oil might just be part of the Middle Three Forks prize. And if you look, Ted also evaluated Middle Bakken versus Upper Three Forks versus Middle Three Forks. The slide on the bottom kind of shows percentiles, and the Middle Three Forks wells aren't as productive as the first bench Upper Three Forks and Middle Bakken, but it's not too far behind, and we're also averaging in some Middle Three Forks wells that should never have been drilled. So with that, I'll kind of close and say, Middle Three Forks, it's probably not going to catch us up to the Permian in terms of recoverable resource, but it could ballpark give another billion barrels into this already multi-billion barrel play. Feel free to follow up with Ted and I at some point in the future, later tonight or sometime down the road. And also with that, thank you for your time.